started this yesterday. Monday will be your last day of new content. And then we'll spend 6 days of review before the final. And then take the final the last 2 days of school.
Do we have both days to work on it?
No, you only have 1 day to work on it. Y'all's final will be the actual last day of school. So on that Wednesday, the second to last day of school, I'm just going to leave a note for the sub to tell y'all to study for your tests that you have that day. For your afternoon tests. Okay? So make sure you bring something to study on that day. And we'll be good. You only have 1 day to work on the final though. So we got this lesson and then one more. And we're done with new material for this year. Okay? So let's get into part 2. Yesterday we multiplied a rational expression by a rational expression, correct? How did we multiply? Just straight across like a normal fraction. How did we simplify? What do we do with the numerator and denominator if we had stuff that was the same? Cancel them out. You got an x plus 2 up top and an x plus 2 in the bottom. Cancel those bad boys out. So today we have a rational expression multiplied by a polynomial. If I give you 1/2 times 5, times 5, what do I need to do to that 5 to make it a fraction? Put it over 1. Same concept if we just have a polynomial. We're going to put it over 1 to make it a fraction. And now it's just a multiplication problem like we had yesterday. Everyone okay with that? So does anything look like it's factorable before I start multiplying? Huh? Let's just take it step by step. The numerator of my first fraction, can I factor that? X plus 2. No. What about the denominator? X cubed minus 27. How can I factor that? I will eventually be taking the cube root of both of them. But what special factoring process is this? They're both cube roots. And what's going on between them? What's another word for subtraction? Starts with a D. A D, as in dog. Difference of 2 cubes. This is a difference of 2 cubes. Because I can take the cube root of x cubed. I can take the cube root of 27. There's a minus sign between them. Right? So, does anyone remember the difference of cubes formula? Say what?
A squared or A cubed?
Not, or a cubed, yep. Minus b cubed equals what?
A cubed equals A minus A squared? A times B?
A minus b.
Cubed.
Now I have, this is the part you were thinking of.
A.
Didn't you say a squared at one point?
Plus AB. B cubed.
That'd be cubed, b squared. So does everyone vaguely remember our difference of cubes formula from back whenever we were factoring? Remember, kind of an easy-ish way to remember it is we have the same sign here and here, opposite signs here and here, and then this sign's always a plus. So for the sum of cubes, it's the same kind of process. We'd have the same sign here and here, so it'd be a plus b, and then we'd have opposite signs here and here, times a squared minus ab plus b squared. So there's our difference of cubes formula. So let's go ahead and use that to factor that denominator. There's my numerator. How do I get a and b?
Cube root
Cube root of what for a, or for a?
of x cubed.
X cubed. What's the cube root of x cubed?
X.
X. Cubed root of 27. 3. My a value is x. B value is 3. Now I can just start plugging into this formula. So a minus b would be x minus 3. What would a squared be? X squared. A times b? 3x. And then b squared? 9. Everyone good with factoring a difference of cubes? Can x squared plus 3x plus 9 be factored further? Using just our normal factoring method? Do I have two values that multiply to give me 9 and add to give me 3? I do not. So now let's go ahead and write this other rational expression. Everyone good with that? Okay, now I can multiply straight across. Is everyone okay if I erase my formula up here? We're good?
Coach, why'd you take the second part of it on the right, but not the first part? So x squared plus 3x plus 9.
That was part of my difference of cubes formula. A squared plus AB times, or plus B squared. I just plugged the x in for A, the 3 in for B. X plugged in for A would be x squared. A times B would be x times 3, which is 3x. And then B squared would be 3 squared, which is 9. Okay? Now multiplying straight across, I get x plus 2 times x squared plus 3x plus 9 over x minus 3 times x squared plus 3x plus 9. So what's going to happen here?
X squared plus 3x plus 9.
They're going to cancel each other out. So what does that leave me left with? Oops, not x plus 3. X plus 2 over x minus 3. Oh, I wrote it as x plus 3 up top. I messed up. So there would be my product. And that'd be my answer. Are there any questions on that? What values could x not equal? Not 0. 3. X could not equal 3. And then I would have to set this equal to 0. X squared plus 3x plus 9. Do what? I can't hear you, I'm sorry.
I was thinking about what it could.
Oh, okay. And we would have to use our quadratic formula to get what that would equal for 0.
Coach, did you just remove the 1 because it's not needed?
Which one?
From x squared plus 3x plus 9 over 1. Did you just remove the 1 because it wasn't needed?
No, just x minus 3 times x squared plus 3x plus 9. That was just being multiplied by 1. Anything times 1 is just itself. So that 1's not necessary in that case. Okay? So does anyone remember the quadratic formula? There's my quadratic formula. How about this? If you have to use the quadratic formula, I'm okay if you skip that step. We'll just say x can't equal 3. Okay? If you wanted to find out what x could not equal also, you'd have to use the quadratic formula here. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. With that, can I go ahead and move on? So we talked about multiplying. Let's talk about dividing now. Let's talk about our regular numerical fractions. If I told you to do 1/2 divided by 5/3, what would I have to do there?
Get the.
Find a common denominator.
That's adding and subtracting fractions. It's a good thought though. Keep that in mind for Monday.
You flip it,
Flip what?
5 over 3.
Why'd you do that?
Because then you can
KFC.
multiply.
KFC. Remember, keep, flip, change. Keep my first fraction the same. Flip my second fraction, so the reciprocal. Change from division to multiplication. Everyone good with that? Same concept with our rational expressions. To divide one rational expression by another, multiply the first rational expression by the reciprocal of the second rational expression. KFC. Keep, flip, change. And we don't need that last sentence, but rational expressions are closed under non-zero division. So, still, we're using all the same processes we use when we're dealing with numerical fractions. They just look different because they got polynomials involved in them. So are there any questions about dividing rational expressions? Makes sense. It's the same as our numerical expressions. KFC. Here it is in mathematical terms. Let A, B, C, and D be expressions with B not equaling 0, C not equaling 0, and D not equaling 0. If I have A over B divided by C over D, just what we talked about, KFC, it would become A over B times D over C, which would be A times D over B times C. Simplify AD over BC if possible. And then it gives us a nice little example down there. 7 over x plus 1 divided by x plus 2 over 2x minus 3. They kept the first one the same. Flip the second fraction from x plus 2 over 2x minus 3 to 2x minus 3 over x plus 2 and multiply. 7 times 2x minus 3 over x plus 1 times x plus 2. X cannot equal 3 over 2 in this case. If I plug 3 over 2 in right here, I get 0. X can also not equal 1 or negative 1. X can also not equal negative 2 in this case. Any questions on dividing rational expressions before we look at our examples? Got 2 more examples, and we're done.
So you only flipping the right side?
Yep. Keep the first one the same. Flip the second one. Change from division to multiplication. K, F, C. Keep, flip, change. Some people like to do keep, change, flip better, KCF, but it doesn't sound like a chicken restaurant if you do that. So, I like chicken a lot. Chicken's good.
I hate KFC.
What? She's amazing. Get those mashed potatoes and gravy with
She
that
works
biscuit.
at KFC. She can see
Oh.
on the inside of it.
Oh, you work there.
Yes.
Can I go ahead and move on?
This second, I'm writing it.
Okay.
Yes, it doesn't equal. Wait, why is it can't equal 3 over 2 again?
Because if I plug 3 over 2 in for x, 2 times 3 over 2 would give me 3. And 3 minus 3 gives me 0, which I don't want 0 in the denominator.
So basically, if you can plug in something and equal 0,
just for the denominator.
Just look it up.
It can be 0 in the numerator.
But we're only looking for a denominator, right?
We're only looking for values that would make my denominator 0.
Yeah, right. We're only
Yeah.
looking for the denominator, right?
Yeah.
Okay.
Yeah.
So that
Because-
clears it up.
0 over a number, if I have 0 in the numerator, that's just 0. That's okay. That's a nice number. 0 in the denominator would be undefined, which I don't want.
I got you.
Okay? Can I move to my example? Examples. Find the quotient. 7x over 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30.
Then find out when you can't equal. That's it.
So what do I need to do, Control?
You flip that mug like a pancake. And then
Flip which mug like a pancake?
the second one over there.
The second one.
The one on the
Do we
right
want to flip the first one?
side. Nah,
We do not.
The one on the left side is the bar you don't flip. But the
So,
one on the right side is the bar.
We keep that one the same, right?
The left side even.
Okay. And then we flip that one, the second one, like a pancake.
Exactly.
Okay. X squared minus 11x plus 30 over x squared minus 6x. I'm still dividing, right?
No, you multiply.
Multiply. Keep flip change. Keep the first one the same. Flip the second one, aka it's called the reciprocal. Change from division to multiplication. Does anyone see anything that we could factor before we start multiplying?
X squared out.
Let's just take it numerator by denominator. So let's look at our first fraction. Can I factor 7x? No. Can I factor 2x minus 10?
Yes.
Does that have a GCF?
Oh, yeah.
What's the GCF? 2. Very good. Brilliant. So I get 7x over. Factor out that 2. 2 times what would give me 2x? X. 2 times what would give me negative 10? Negative 5. Everyone good with that? Caden, you good with that?
Well,
You good with that?
to be honest, I would
Okay.
pay attention like he was. I was right.
-5 and -6.
Is everyone okay if I factor this without using my T-chart? I just kind of draw my parentheses and ask y'all what needs to go in there. We're dealing with x. What are my two signs?
Negative.
They're both negative. Remember, if that value, or if that sign in front of our C value is positive, I know they're both going to be the same sign, and that sign's going to tell me what they're going to be. So they're both going to be negative. So now I'm looking for two numbers that multiply to give me 30, add to give me negative 11. What are those numbers?
-6 and -5.
Negative 5, negative 6. Everyone okay with that factored form of that numerator? Fantastic. Let's look at our denominator now. X squared minus 6x. What's the GCF there? X. X times what would give me x squared? X. X times what would give me negative 6x? Negative 6. Everyone go with all my factored forms. Perfect. Let's go ahead and multiply straight across, and then we'll start canceling stuff out. So I have 7x times x minus 5 times x minus 6 over, I have this 2, and I also have this x. Is everyone okay if I put those next to each other to make 2x? And I have x minus 5. Oops. X minus 5 times x minus 6. So what's going to cancel out here? What?
X minus 5.
X minus 5,
X minus
x minus 6, and my x's cancel as well. So what am I left with? 7 over 2. There is my quotient. Can 7 over 2 be reduced anymore? It cannot. So that's my quotient. But I need to specify what? What can x not be in this case? X cannot be 5. What else can x not be? X cannot be 6. What else? 0. Any questions on that? If I plug in 5, I get 0 in my denominator, because 5 minus 5 gives me 0. 6, if I plug that in, 6 minus 6 gives me 0. 0 times everything would give me 0. If I plug 0 in for x, 2 times 0 is 0. 0 times everything would give me 0. Questions on example 5? Not too bad? Keep flip change. Flip it like a pancake. Can I move to my last example? Huh? Okay. I'm going on ahead. Okay, now I'm dividing a rational expression by a polynomial. But, hopefully, we all know how to handle this now based on my first example. If I have a polynomial just by itself, how do I make it a rational expression? Put it over 1. And now I've got a rational expression divided by a rational expression. What do I do with the first expression? Keep it the same. 6x squared plus x minus 15 over 4x squared. What do I do with my second fraction? Flip it. So now I get 1 over 3x squared plus 5x. And then what do I do with my division sign? Change it to multiplication. All right. Can we factor that first numerator? How am I going to have to factor this? What does this mean? What? Very good. What do we call that?
Slide and divide.
Slide and divide. Got to multiply my 6 times negative 15. So that'd give me x squared plus x. 6 times negative 15 would give me?
Hold on. How would you know to look for that though?
So, the way we've been factoring, where we just draw the parentheses and look for the numbers that multiply to give us our c value, add to give us our b value, they all had a leading coefficient of just 1. There was nothing in front of that x squared, correct? So if I've got something in front of my x squared besides 1, in this case 6, I got to slide and divide. Okay? So now I can draw my parentheses. What are my two signs? Plus, minus. And now I'm looking for two numbers that multiply to give me negative 90, add to give me positive 1. What? Which one's negative? Negative 9. So I get x plus 10. Did you say that? Oh, okay. So I get x plus 10 times x minus 9. Is everyone okay seeing where I get those numbers from? 10 times negative 9 gives me negative 90. 10 plus negative 9 gives me positive 1. And I stop there, right?
Yes.
You have to add the 6.
I have to what?
Add the 6 to the front of the equation, right? Because you divided it.
What do I have to do with it?
You put it in front of the x, but then you have
I don't put the 6 in front of the x.
You have to take.
What's this process called? Slide and divide. Have I divided by anything yet?
You gotta divide the other side by 6.
I got to divide both of these numbers by 6.
to.
10 and 9. 'Cause that's what I multiplied by earlier. Everyone okay with that? This is a good little review of slide and divide. Let's reduce these fractions. 10 over 6 reduces to 5 over 3. 9 over 6 reduces to 3 over 2. Everyone okay with that? What's my last step for slide and divide? Very good. If I don't get a whole number after I reduce, I got to take that denominator, put it in front of my x value. We call it bottoms up. So 3 comes from the bottom. Oops. 3 comes from the bottom and goes up. 2 goes from the bottom and goes up in front of the x. So I get 3x plus 5 times 2x minus 3. And those are my two factors of 6x squared plus x minus 15. Is everyone okay with that? So that's what I get for my numerator over here. 3x plus 5 times 2x minus 3 over 4x squared. Because 4x squared can't really be factored into, can it? Questions on that first fraction? I just have 1 in my numerator of my second fraction. Do I have a GCF of that denominator? What is it? X. X times what would give me 3x squared? 3x. X times what would give me 5x? 5. So now everything is completely factored. Questions on any of it? Can I erase my lovely slide and divide work over here, as well as this top part?
You're not finished, is it?
We're not done, no. We're getting there, though. We're close. I know. It's good stuff. Now I can just multiply straight across. So 3x plus 5 times 2x minus 3 times 1 will just give me 3x plus 5 times 2x minus 3. Everyone agree with that numerator? And then when I multiply 4x squared times x times 3x plus 5, what am I going to get? 4x to what power? To the third power, cubed, times 3x plus 5. Everyone okay with that denominator? Do I have anything that's going to cancel? 3x plus 5, so I'm left with 2x minus 3 over 4x cubed. Here would be my quotient. Any questions on that? Not too bad. What does x not equal? X cannot equal 0. If I plug 0 in, I get 0 in my denominator. What else can x not equal? Based on my 3x plus 5.
It cannot equal 5. Or it can equal negative 5.
Well, if I plug negative 5 in, I get negative 15 plus 5, which is negative 10. That's fine. If I don't know what it cannot equal, what can I do with the factor 3x plus 5? Set it equal to what? To 0 and solve for x. Negative 5/3. So you take it, 3x plus 5, set it equal to 0. Subtract 5 from both sides. Divide by 3. Negative 5/3. Does everyone see that? Can x not equal anything else? Or are we good?
I think we good.
I think we're good too. Are there any questions on that? Here we go. Pages 384 through 385, numbers 19 through 34 all. Due Tuesday the 18th on Canvas. Are there any questions before I end my recording?